In this video, we have three integrals to evaluate. They look very similar. The denominator is the same for all three, x squared plus 2. One has a numerator of 4, another one of 4x, another one of 4x squared. Let's see how similar the integration procedure for each will be. We look at the first one. It has to look, or it can be put in this form, du. You can write this as u squared plus a squared. So there's a formula that states if you have the integral of the form du over u squared plus a squared, or this could be a squared plus u squared, the same thing. The value of the integral is 1 over a. You can say either tangent inverse or arctangent of whatever u is over a, plus the constant of integration. Well, if you look into the first one, I got a 4 right here, but it's constant. I could factor that 4 out, and then that would be a dx on top. I got an x squared, but that could be the same thing as a u squared. Got a squared, but 2 can be written as the square root of 2 squared. So that has this form. You can take out the 4 if you want, or you can just leave it there and just realize that it just multiplies what the answer will be here. So this is equal to then 1 over a. In our case, a is the square root of 2, so this will be the square root of 2. And then this could be tangent inverse, or you can call it arctangent. And this would be u over a. And like I said, in our case, u is x. So this would be x over the square root of 2. And then you could rationalize and plus the constant of integration here. And you can rationalize this and write this as the square root of 2 over 2 here. Same thing over here. We have x over radical 2. You can multiply numerator and denominator by radical 2 to rationalize it. I'll let you take it from there. But this is basically the answer. The second is a little bit different because you have a 4x here. So in this case, what we'll do is we'll let u equal to the denominator. Then du would be the derivative of x squared plus 2, which would be 2x dx. Derivative of 2, of course, is 0. And then we got right here x dx. So the x dx, they divide by 2 here. The x dx could be replaced by du over 2. So this would be du over 2, and that'll divide into the 4. So this could be given as the integral of 2 du over u. So anytime you have a constant over u, integrate it with respect to u, that's just your natural log. So the 2 comes along for the ride, so this will be 2 natural log of u. But we're going to go back to the original variable, and u in our case is x squared plus 2, and x squared plus 2 can never be negative, so we don't need absolute values here. We just write x squared plus 2 here, and it's plus the constant of integration. So this one didn't involve the tangent inverse or arctangent function. You simply get 2 natural log of x squared plus 2 plus the constant of integration. The third one again has the denominator x squared plus 2, and the numerator has 4x squared. It's a rational expression, but I wouldn't even consider partial fractions here. A couple of ways we could break this down. Let's just do it this way. Since the degree of the numerator is larger, let's divide. So 4x squared is divided then by x squared plus 2. So x squared into 4x squared gives me 4. And we multiply, we get 4 partial quotient times the divisor, so we get 4x squared here. 4 times 2 is 8. And then we subtract. 4x squared subtract 4x squared cancels. This is going to be a 0 here. 0 subtract 8 is minus 8. And then we can rewrite this. 4x squared divided by x squared plus 2, we get a quotient of 4, so this will be 4. And then it's plus. The remainder, in this case, is minus 8 over the divisor, so we get minus 8 over x squared plus 2. And we're integrating here with respect to x. So we can proceed then. Don't have to break it up into two integrals, we just do it term by term here. So 4 integrated with respect to x is 4x. And then you can look at this integral. It's just like the first one now. See, the first one had just a constant, didn't have the x. This one just has minus 8 here. So this integration here for this one is going to be the same using this formula right here. So it's going to be a minus 8 comes along for the ride. And then you look at the integral of dx, x squared plus 2. That's going to be your tangent inverse here of u over a. Again, u is x in this one. And 2 can be written as the square root of 2 squared. So a is the square root of 2. And then a also divides this coefficient here, square root of 2. So we can simplify this a little bit. 4x. Then rationalize here, multiply by radical 2 here. 2 will divide the minus 8, this will be minus 4 here, times the square root of 2. Just multiply numerator and denominator by the square root of 2. And got minus 4 square root of 2. And this is again times the tangent inverse of x over the square root of 2. And I could also rationalize here, multiplying by the square root of 2, I would get the square root of 2x over 2. I'll just leave it like that. You can take it from there. Then the constant of integration. So 4x minus 4 square root of 2, tangent inverse of square root of 2 times x over 2. Thanks for watching. We'll see you next time.